Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss about what is in data mining, and next we will go for the prediction, the classification of data mining as a prediction, how we can deal with the prediction in the data mining, the association also in the data mining. Prediction and classification and association. These terms we will introduce in the term called data mining. We know that data warehouse gives us an information as a collection of this data from diverse sources with an unified schema. Now, data mining comes with a data warehousing concept where we can mine through the data warehouse to find a particular pattern or some useful rules or classification by which we can get more data that are inputted to this data warehouse put to the particular portion on which if they belong they can purposefully serve an original product. Now, what happens by producing this much products inside and data mining? This mining effects on this data can be produced by having a classification of rules. Now, what do you mean by rules? That is a knowledge that we can gain from this data mining technique on which we can say that make it as a rule, and then the rule can be defined and used as in purpose of having the data to be put and fetched in a particular query. Now, what are the basic use of a data warehouse? That we can have now from diverse resources information that belongs to an same infrastructure. That is the plus point of data mining too, that now we can build on that data warehouse a particular knowledge, but that is different from the deep learning or the machine learning. In machine learning, we had that all types of data that was stored inside an knowledge base can be considered a much smaller than the data mining where the data warehouse is a large collection of information. And also it is not like this deep learning or the machine learning in artificial intelligence which keeps on a knowledge base. Here also we are using a knowledge but just from the data on which we can logically build a knowledge. But for the artificial intelligence, it's inferred some rules to it on which it can build the data so that it can produce new data. But for data mining, we are not able to produce new data. We can sort the data that we can have, and then we can build some classification or which we can get some result on which we can build the particular infrastructure of a database. Now, say suppose that from a database or a data warehouse, we had the information concluded that the young woman which is greater than the 50,000 of income is more likely to buy the small sports car. This is not a universal truth. Maybe this is true for a particular region of a country or for a world. Now, when we are considering this as a rule, that means we are considering only for that enterprise that rule. So it is more like data-oriented rule that we are having, not a general rule that we can apply to any of the database so that we can achieve a particular section. So this needs both of the confidence and the support of the designer. That means the designer need to be smart enough to divide the data in such a way so that it can lead to an classification which will be beneficial for that enterprise for this data mining. Now say that the patterns they are found in this data mining can have three types of association. One is the prediction, next is the association rule, and final is the clustering. First we will talk about the prediction. So prediction is based on the attributes that we can have in the data warehouse. So prediction is more the field oriented data that we can have. Now build on these attributes, it can infer some classification or it can infer some prediction so in which we can build the result and classify the attribute on an item into that category. So it is more like a categorical distribution. See, suppose that I want to fetch the credit information of a person. So the credit info is my prediction that we need to do based on the attributes like the age, the income, the balance of that person inside the bank, these three categories. Now based on these three categories, also based on the degree that it have, we can predict the credit info on that particular person. Say that the credit card will be allowed to the person or not, or how it can calculate the credit skill of that person. If it is in good, excellent, or bad, we can categorize this based on these fields that we are having. Now the fields together can be combined to give a prediction. Say suppose that who is greater than age of 50, also whose income is less than 75,000, and whose bank balance stays moreover average than 1 lakh. This three considered to be an excellent holder of a particular credit skill. So now it goes with a prediction excellent. See, these predictions are not always true, but we can make this category in such a way that they will be true at its extent. That means we can have the excellent category at least 0.9% on this we can fall by getting these three attributes and the prediction on these attributes. The next type of the data that we can mine through is the association of data. See, the prediction is more oriented with this field, but the association is more oriented with one field that can associate it with another field. See, for the books relation, which have the book name, the book author, and the book price. Now, the associator or the data miner designer can design it such a way that it can associate it with any of the name, author, and price of that book on the attributes of this book relation, so that it can have it associated many other relation. Say suppose that for B author and B price that the data mine designer has targeted. That means if the books of a particular book, say Harry Potter, so it goes for the author Rowling, or it goes for the price of that book, or even it goes for the name of the book. Say suppose that a book has got 1 2 3 4 5 6 7 series, so someone is buying this book for Harry Potter 1 series, so there will be a possibility to show him the advertisement with the related data that is generated from this B name attribute, that it can be shown for 2 3 4 7 versions of this book, so that he can be attached and get this association to get attracted and to give an exploitation on this advertisement that they are more intended to buy. See, this B name Harry Potter 1 has one is buying. So the tuple from 237 based on a particular attribute is now showing as an advertisement. Another thing we can do this for author. Say for it is Rowling. So we can go for find what the books the Rowling has written and then go and advertise all the book names associated with the book that is being purchased. Or either we can go for the price also as in category prediction as well as association. That means if it is belong to $50, then it belongs to all the books and shows the advertisement which belongs to $50. That means the $50 range books that can be shown. Now this advertisement on this association need to be done in a logical way. Say suppose it will be more acceptable by the buyer, for which if we have made association with this B name and B author rather than B price, because it is not absolutely mindful for an buyer that he is searching for books that belongs to this $50 category. But it can happen that he wants the book that is written by J.K. Rowling. Okay, now I want to read this type of book, and now I can go for another series of this book for buying. So this is like exploiting the buyer's nature or the buyer's mind to get advertised this type of associations. Now, this is all about the books that is named with the association on an attribute. It can also possible to create association that is related to another table. Say for the example that someone is buying a camera. That means buying a camera means the camera's accessories are important for him too. So while buying a camera, the advertiser may advertise some of the accessories that is extremely useful for that particular camera. So now the association will be built on the decision that what are the accessories that is absolutely exclusive for that product, not just all the accessories that belong to the camera. Say for a particular camera, there is some particular accessories that is built for that camera. So better choosing that attributes or that relations as our association in the data mining will become absolutely important while having the decisions on this advertisement made. Now this is all about a pattern that goes for a descriptive patterns, that first the data miner need to go through all the field names, and then from it finds an association with the attribute name from that relation or the tuples that belongs to that relation. Now another type of descriptive pattern points is the clustering. Clustering is like grouping the data together so that itself it can describe an character. Say for the heuristic research for a disease for a country. So we can measure that all the disease name that which year it is happening. So it can go for the disease name, the year, the victim number, on which we can see that for a particular year, say 2010, there were more victims on the disease typhoid. So in this way, we can also predict on associate on a cluster rather than for demand on advertisement and all. So it is more like a cluster that we are making the data all together, like for all the tuples that belong to the disease relation that goes for the same name, the same year, and also belonging to the same victim numbers. So now the attributes that we are choosing is entirely important for the data mining for either the prediction, association as well as the clusters. So now we know that basically the data mining is based on the predictions. So we will now go and classify the prediction according to many of the classifiers that we will introduce today. Now the statement classification gone for a training instance. Say suppose the training instance is based on the data that is already being stored in the data warehouse. Suppose we have the relation customer in such a way that the customer table is containing the customer ID, the balance, the account number. As for the bank's information on the customer, so now the customer relation is having the CID, balance and account number as for the bank information, and again the C personal on the customer's personal info we are having his age, degree, or we can have the income of him. And for the customer's credit info, we can have the customer credit relation. We can give that what is the credit score of that person or the customer ID of that person. Now, when a bank decides to give this customer a particular credit card, so before going to the credit card, it goes for a training instance. That means from the data they are having, it builds some classification. It builds some instance on which we can train the data for a particular set of transactions or set of tuples and see how the transaction on the customer has evolved from the past year. Say for we are considering the year-wise balance on this customer. So we are adding up one more account here on the year. So we can see that from year wise what balance he is having. Is it improving or is it decreasing? About the income, that is it improving or decreasing, based on which we can give him the credit card information by the bank. Now also the annual income, the educational degree and the age of that person also matters in the credit card, because it defines that the person can work for how many more years. So built on these three relations, we can give and produce and rule or the base on the knowledge, so that we can define the credit card on its credit info as the good, excellent or bad. Now let us define some rules so that we can have a concrete idea of what we can have for the good, excellent and bad category. See for all person P, that means we are belonging to the relation person and we are taking an instance at P whose P dot degree is equals to masters and P dot income equals to 75,000 or greater than equals to 75,000, then we can say that its credit is excellent. Now either also we can choose for that someone is not that much educated but his income range is high. So how can we do that? We can do that by for all person P whose P dot degree is equals to bachelor or P dot income greater than equals to 25,000 and P dot income less than equals to 75,000. That implies this P dot credit is good. So now we are choosing between either the person is belonging to the degree bachelor or it belongs to the range of income 25,000 to 75,000. So in this way, we can either go for an attribute, another attribute combination to decide a knowledge base, or we can use a set of attribute that can go alternatively for choosing a knowledge base. Now this set of data which we are choosing for the selection of the statements are known as training set, which is a training instance part. So the training instance together can be built to a training set on which we can decide and force these rules to can build an infrastructure of the knowledge base for which we can data mine on this data warehouse. Now we go for the classifier. The most primitive type of classifier that we can know is a decision tree classifier. Now the decision tree classifier is a tree whose roof node on this particular infrastructure is the built-in condition or the first condition that we can infer from a database knowledge. And now when we are going to the leaf nodes, that means they are the rules or the situation that we can conclude from the decision trees, or they are the ultimate condition that can be built to the take decisions. Now the non-leaf nodes, and also it is not a non-roof node, can be considered as the classification to the root node. That means if the root node is not enough for classifying the tree in such a way so that we can build from the root node condition, there are 3 or 4 more conditions based on that particular attribute on which we can combine other attributes as a leaf node. So this type of tree is known as a decision tree, and this decision tree classifier is based on a top-down approach. That means it is recurring in a top-down way or the backward way. First we need to take the top node, then we go for the non-leaf and finally the leaf nodes. So in this decision tree classifier, we have as the node all the attributes, and the ages are considering the values to their attributes or the options that we can generate for the attributes. See, suppose having the credit card information, the primary attribute is the degree. So we will have at the root node the degree. Now say there are four types of degrees that is associated with the degree variable. One is no degree, bachelor degree, master's degree and doctorate degree. So now we can have four edges that is associated with this node. No, bachelor's, master's and doctors. Now after that we have gone to each of this category. Maybe there are more categories or the non-leaf node which can be decided to take the knowledge base. Say for the next type of category is the income. So combining with the degree, we have the income. Say when we have the AND clause inside this training set of data, we need to put that is a root node as the first one and the next node as the AND combination one. So now for the degree, there is one with the income. Now see, if the degree and income goes with an OR clause, then we cannot have the non-leaf nodes as a part or the children of the root node, because the degree or the income both can be the root node. So what we can do, if there is an OR clause, we can draw the two decision trees based on one as an income as a root node, another as a degree as a root node. Now with this node on this income, that is a non-leaf node, as the leaf node will give us the decisions. So now say the income ranges in three categories for the no degree holders. Say there are four categories of data. The first one, red, is for bad. The next, blue, is for average. The black is for good. And finally the green is for excellent. Now associated with each leaf node, we can have only these four results as the leaf nodes. Now first we need to write all the conditions on which we are dividing it. Now we can look at this, that for the income that is less than 50k with no degree, that is considered to be bad, and the decision taken on also the degree and this consideration of the income. Says for the same 25 to 75k, we have this income of doctorate also and the masters also, but it belongs to the masters category of 3, that is the bad, good and excellent, but for the doctorate we have only good and excellent. So in this way, differently on the income and based on also the degree, we are having the conditions concluded of each of this leaf item. So now we can say that the leaf items are the final conclusions, the non-leaf node are the conditions that must be associated with this primary condition as the root node. Now how to build this decision tree? We are now following in greedy algorithm. What is a greedy algorithm? That combines the most related data together. That means it relates the data like less than 50k, less than greater than 100k, belong to 50 to 100k, as close as possible to these categories. So this is all about the partitioning attribute. So now my best partitioning attribute is income, not the degree, because degree is the classifier and income is the partitioning attribute. Degree is not partitioning for this different classes. See, the degree is the classifying on the identifiers, and the identifier itself are classifying into the classes. So there is one partitioning attribute, another is in the classifier degree, which is at the root node. So this is basically for this root attribute on the greedy algorithm. Now how we can continue this greedy algorithm? The first, we are classifying our degrees so that we are beginning with an group of data. Say for the master's group, the bachelor's group, the no group and the doctorate group. And now also with this one, we can have the incomes as this data. That means we are now having the incomes as the classifiers or the partitioning attribute on which the actual decision has been taken. So in this way we can build the decision trees. Now we know that how can we best split the needs. Now we can see that if there is no one that belongs to the category that is no degree holder, That means this node or this path degree none to the income 50-100K good is becoming absolutely null for this 3-1 belong to this classifier that goes with an empty relation. So we must choose a classifier in that way so that we can have at least an average numbers of persons or data that is associated with each classes that the classifier is having. So that is the best condition for having a best split. There are numerous formulas that we can introduce to have our best splits. Now we can start with a training set instances so that we can better understand what is an best split condition. So if we start with a training set, say for an instance, the persons who belongs to the income range 75K. Now we can see that the persons who belongs to this no group income in this 50 to 100K, as well as the bachelor degree holder for this 750K, or the master's degree holder who is from this 25 to 75K, and the doctorate degree holders for greater than 25K, all that belongs to the same class on this different identifiers. Now we consider an decision tree as an impure one because it is having different instances of different classes. That means now we can have some of this no degree holder, some bachelor's, some master's, some doctorate. That means my classes are not split in a best way. The pure decision tree classifier will be one when one training set instance can have the best one. That means it is considering to be the instances of only one class. That is the pure one, and the way we are involving other classes, it is becoming more impure. That means if we make our tree till this one, then we can have only an impure one. Otherwise, if we can have this income as the identifier or the classifier, then also it will be leading us in an impure classifier tree. Now, how to reach an pure classifier tree? To introduce more nodes as a partitioning attribute that will be attached to the root node or the classifier. Now, there are different measures by which we can calculate the pure and impurity of a particular decision tree classifier. Say there are S on this K classes and an instance I in this relation S is Pi. Now there are many measures by which we can calculate the purity. The first one is in Gini measure. So we can calculate the Gini of a standard classification so that we can know that the Gini is increasing or decreasing depending on we will specify our purity. See, we are having the square of each of the instances and all the K classes that belongs to I minus 1. Why I have made this I minus 1 here? Because I am having the 1 on this instance of the training set and then subtracting all the values from that training set. That means the 1 will be calculated as a whole and in purity function, and now we can have this one as and intention to 1. That means if the limit is put to y minus 1 to k, then all the instances, if it belongs to the same class, then this will predicted to be assumed as 1. So now the purity is measured is the most pure function, the I minus 1 to k pi square goes to 1, that it tends to be an 1. So now I can have 1 minus 1 0 to have the pure classifier. Now the maximum value that it can reach is the from pi square is 1 by k. That means the number of classes from which one instance is taken. So now my Gini will become 1 minus 1 by k, or we can say k minus 1 by k. So that is the most impure function that we can have according to the Gini measure. So this actually measures that a very simple one, that how many instances that we are having from each of the classes. If all the instances belong to the same class, then all the pi will belong to the same class. Thus having it, we will have 1, which will be 0 for the purest one, and for the impurest one we will have one instance of different each of the class. And now we can have k minus 1 by k as the most impurest one. Now the next one is an entropy measure. What do you mean by an entropy measure? That to calculate that to what degree the instances can belong to one class. So we calculate the entropy of S as, see now in this entropy, other than the Gini measure, we are not multiplying pi directly to the pi, but pi with the log value of pi. So now again with the log value of pi also, if it is belonging to the same class, then we will have this log 1 equals to 0. So my value will be somewhere near 0 for the purest one. And if we have some value that is positive, that means the number of instances equals to the entropy. That means it will be negation of pi. So now my entropy will have pi instances, that means one instance from each of the classes, then the entropy becomes pi to have the impurest one. Now the entropy directly derives from the information theory, that we have information about this particular pi or an instance of a particular relation, then we can have the entropy calculated from it. Now if S is divided into different classifiers or identification and partition attribute, say for the degree is again divided into income based on these conditions. So now we can have S which is in set of, so now belonging to each of this section, we can have the purity of that section defined by that purity of S1, S2, SR is equals to, so for each SI from 1 to R, that is the section of it, we need to calculate the purity, the atomic value of that particular instance divided by the total instances plus. So now we can have the purity defined as this one. So if it is tends to be 0, it is the most pure one, and other than that it is the impure one. Now how it is information that we are gaining from an purity or the section that we have divided. Say for an instance that the classifier degree is divided into the partitioning attribute income. Now what is the information we are gaining? That the degree of this particular purity and the demands purity, that means each of the instances purity. If we subtract the purity from the non-leaf node from a leaf node, then we can get the purity of an information gain. That means how pure the information that we are gaining. So if we can subtract the purity of the total decision tree classifier S with all the partitioning attributes purity, then we will get the information gains purity. Now whether the information that we have gained is particularly useful for a single decision tree classifier, or as we have prescribed earlier that we can have small decision tree classifiers onto which each of the element has 0 or 1 elements, would make a big difference. So now the information gain is not the whole on a decision tree classifier, but an whole part of this each of the classifier on this partitioning attribute. So now we can have the information content of each part of this classifier by defining the entropy of it. So now the information content on S, which can be derived from each of the S1, S2 and SR, that means all the small decision tree classifiers based on the partitioning attribute, can be defined as, now the same entropy function that we have defined previously with each instance pi that belongs to the S. Now we can have each instances, that is Si by S, multiplied with the log of that person, so that we can have this minus 1 or I minus 1 to R data instances for the information content on each of this. Now if it tends to be 0, then it is the most pure instances that we can derive, and if it is got any positive value that is in increasing nature, so that will be a more impure function that we can generate from it. So now the best split goes for the most information gain ratio. So how can we define the information gain ratio? So the IG ratio is equals to the information gain on a particular decision tree with an information content. So this is the best split that we can have from this IG ratio. So first we have described the Gini measures, then we go for the entropy, then the information content based on this entropy. Finally, we have gained the information gain and then compared this IG ratio on which we can gain the best split on this. So the IG ratio is higher. That means whenever the gain is better than the content on that race, then we can have the best split. That means we have splitted the decision tree in a way that there are more instances that belong to the same classes now. Now, after the decision tree has been splitted, now from the user, how it can find that it belongs to the best split category. So it can be two types. One is the continuously valued, another is categorical values. For the continuous valued, it needs some of the partitions to get conditioned. That means it needs some numerical values like age, income, which can continually increase with the numbers on that particular data. Now there are some category also like the degree. So if we divide our splits in the categorical, then we are having the type of category to be divided into different sections. Now each of the slit that is having the continuously valued or the numerical values is considered to be better or the best split rather than we are having in string or categorical values, because the numerical values can generate us some binary splits. The binary splits means that the tree is divided into two parts. First is the less than category, greater than equals to category. But for the categorical splits, we have the multi-way splits that can have more than one parts. That means we can divide the age in some categories from 0 to 50 and 50 to 100. But for the multi-degree, that is a multi-way split for the string attributes, say suppose no, bachelor, masters, or at least doctorate. So we cannot have these ranges that we can go for this categorical fields. Now the multi-way splits are more complex and are considered to be less best compared to this numerical or the continually valued splits, where we can have this continual value on the splits mechanism that we can make on this two category less than and greater than equals to. So there is one definite category. Say for the data training instances 5, 10, 15, 25. Now we have two categories to us, that one is less than 10, another is greater than 10. So the equals to 10 we need to include. Here I am equals to 10 including in this greater than. We can also introduce into lesser than. Now based on this we can have 5 and 10, 15, 25 as a result of this split. But we cannot have like this less than bachelors greater than masters, because there are many degrees that is more than masters and many degrees that is less than bachelors. So this is more possible with a numerical value to go for the best splits, because they are the better partition attributor where the categorical values are better classifiers. Now, how to construct a decision tree based on an algorithm? See that we have found the best splits on the maximum information gain ratio with the help of the information content and information gain. And now we also know that the numerical values give the best splits rather than the categorical values. Now, how can we construct these decision trees recursively? Why we are using the term recursive? Because already there are some training set and based on which we need to make our beta so that we can make our decision tree. So let us first calculate the algorithm for finding a decision tree. We are introducing one procedure, that is growth tree, which is considering a single decision tree S, and inside that we are creating partition for that tree. Now we are defining the procedure partition S, which we are calling from the growth tree partition. Now see, we are taking that the purity and the size on that particular relation. So now we have two cutoffs, del P and del S, as del S is the maximum or the minimum value for this purity and size. Say the maximum value of this purity is del p, which is equals to more than 0, and now the del s is the minimum size that it can occur in this decision tree. That means at least one root node with two classes can be there. Now we can calculate if the purity of S is greater than del P. That means it is not possible if the purity goes beyond an cutoff, and also the size is less than the minimum size of a decision tree, then we cannot partition the tree anymore. Now, if that doesn't happen, then for the tree that we are taking, we need to partition it. So now we are taking each of the attribute as the partitioning attribute. So if it is a partitioning attribute, then we need to split on A. That means the categories like the greater than 50K, less than 50K, 25 to 50K, these categories we need to split on. Now we need to find the best split for all A that belongs to this partition and put into this S. That means each of the sections now are put into S1, S2, SR as my final information that we can have. So now we are having splitted each of these sections. Now further, if we go for the partitioning, then we need for each of this S and to partition again if it is possible for satisfying the purity and the size of this S. So now we can see that we have made the partition and make and grow tree or a decision tree from the root node to splitting up the partitioning attribute, and if possible then again splitting up until and unless we found the purity to be as pure as it can. Now some of the specification based on the construction algorithm, as we have seen, make the subtrees overfitting. When we are setting the overfitting of a subtree, that means the subtree is turned to be the highly concentrated training data set when they can have another subtrees which is less concentrated with the training set. So this is now we can prune the data in such a way so that we can have all the average subtrees as the result of the training set belonging to the most classes as minimum as possible. Now if you look at this example, so now we can see that this degree equals to masters and income is greater than 75,000, then we can have the credits equals to excellent. That means the left hand side go for the non-leaf nodes and the right hand side go for the leaf nodes. That means now we can have the left hand side as the classifier or the most prominent classifier which can make classes to it, and the right hand side has become the pruned way so that we can have a better result on the majority of the classes belong to that right hand side. So in this way we can construct our decision tree classifier. So other than this decision tree type classifier, there are two more type of classifier. Was in Bayesian tree classifier, another is the partition where we can have for the support vector machine classifier. Now we will discuss about the Bayesian tree classifier. Now if we take that the probability of an instance D that belongs to class Cj as this PCjD, then we have the Bayesian theorem is as followed by. Now we can have that the D will belong to the class Cj by the probability of giving that they can generate D instances based on the training classes Cj, and there is the probability of occurrence class Cj by Pcj, and also we can have the probability of the occurrence of D instances by Pd. So now we can have if the class can generate D instances with the probability of the class that will happen divided by the total probability of the occurrence of the instances, then we can have the probability that the D instance will belong to the class Cj. So this is the classifier that is most used in this type of big business issues where the Bayesian theories is better than the prediction. So it is also based on a prediction, but it is not the decision tree classifier. We just get one tree attribute and then classify it according to the partitioning attribute or more like conditions. Here the Bayesian theorem is based on more like the probability that what we can have. Say suppose that the excellent type of credit info is 0.1%, where the good type of info is having 0.8% and 0.2% for that excellent or bad combination. So how can we define the naive Bayesian classifier? The naive Bayesian classifier can be defined as, so when we are introducing the term naive, that means we are having each instances of the class. So here we can see that the total probability of the decision or the instances that can be generated from CJ or the class CJ is that the probability or the product of the probabilities that the first instance can be generated from CJ, the second instance of the training set can be generated from CJ, like the n instance can be generated from CJ. So now we need to check for each of the tuple and then see that we can give it on the class CJ or not. By this we can classify this naive Bayesian classifier. The next type of classifier is a support vector machine classifier, where the vector machine means it is vectoring the conditions that we can have and then putting down in a graph we can see that what are the values that is beyond the limit and what are the values that we can get in the limit and the best one to find. Now we can see that some of the vectors that we can define based on an attribute again, and we can build and vectors of each of the attributes to have the predictions to be happen. Now that we are given in a two-dimensional geometrical plane on which we are given A and B, two classes, and from which we have to generate the pointers on which we can be predictions on the data instance D. So we can put the lines along with this classes A and B as a vector, so to define what is the maximum extent that we can put to one class, and then we can see that what are the variations that we can have from each of the class. The vector machine is important because by geogrammatically it is extremely easy and smooth way to rectify the classes and then belong each instances to the same classes as most. Say suppose that the class A will belong to one side of this graph and the class B's point will belong to other side of this graph. So by the vectors we can plot that all points that belongs to class A to the one side of this graph and other points that belongs to class B can be the other side of this graph. Now we can draw a maximum margin line that can go from one class A to class B. That means, say the maximum margin line appears somewhere here. That means for the class A, it can go from this to this region at its most. From this margin, the class A cannot move. That means we can have the maximum margin or the minimum margin by defining these support vector machines. Also for the class B, we can have such territory, which is the extreme marginal territory for class B. Now, if some line lies in both the class A and class B, then we can consider dash value are the most dangerous or the most victimous values. Say that these two lines where we are having that crossing at margin line A. That means if we margin class A with this line and margin class B with this line, then we can say that we have an overlapped section of both class and class B because it lies within this point where we are cutting the marginal or the maximum margin line. So by this way we can also classify by putting all the data instances by dividing in two geometrical plane and then have the result with a maximum margin line, the minimum boundary and the cutting instances of each of this line. So this is the classifiers that we can have based on the predictions. Next we will discuss about the regression techniques. The regression of data is more related with a value rather than a class. That means we are regressioning on a particular value of a data. Say for an instance, if we have a set of data, now on this set of variables, we want to predict the value of an variable y. Say for x0, we can have the value of y. Such in this way, we can have all the values of y. Now, how we can regression making on each of this data? We can use this formula. So we are introducing the coefficient set A0 to An. so that we can have the value of y as this one. Now this is a linear progression because we are increasing the coefficient as well as the data set value to it. So this is a linear progression on this regression. Now this we want to fit in a curve on which the values can be put to. Now whether the curve belongs to the particular value of y or not, say for the first curve it belongs to the y, but the second one it is doesn't. So we know that linear progression as curve fitting also, because it fits the data in a curve so that we can gain the better knowledge on this data. Now that we have made all the classifier, one we need to associate with each classifier and validation rule. So the four validation rules are true positive, true negative, false positive and false negative. That means there are some way that it seems to be a positive classifier, but when we put that in an associative rule, we found that the classifier is not true, rather it is false. But the condition on which the prediction was made, that was positive. So now according to which we can have these four classifiers. The first one is the accuracy. The accuracy means the fraction of time the classifier gives the correct result, and it can be calculated by, that means the total number of positive plus the total number of negative. If we fraction with the true positive and true negative summation, then we can have the accuracy as the fraction of time. Next one is the recall, or we also call is an sensitivity. That means it gives us the result where the term we have positively defined and how many times or the fraction of time the positive was a true positive. That means we have made it a positive and it becomes a true positive. So that is the ratio of the true positive by positive. Next is the precision. That means how much precise our prediction was. That means it is the true positive over the positives that we have calculated. That means it is the true positive divided by the true and false, both the positives. And the last one is the specificity. The specificity is the exact opposite of sensitivity, that how much specific our result is, that if we have make it an specific negative and how much time it was true for the negative. So it is known as the true negative by negative or the false negative divided by negative. So in this way we can calculate the accuracy, the sensitivity, precision and specificity of a classifier that we have made. So that is all for the data mining techniques based on the prediction, association as well as the clusters. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.